Hey everybody, Chris with Trimble Forensics. All right, so this week's Wednesday workshop webinar, WWW I guess. So this week's Wednesday workshop webinar is all about missing the mark. What are you missing when you're laser scanning your crash scenes? And more specifically, tire marks. Now, it doesn't have to be just tire marks. There's a lot of things that can get missed with laser scanning if you aren't careful. And so that's something that I'm going to talk to you about today is what are you possibly missing at your crash scenes that you don't know you're missing? And also, when, we're going to start it off with a problem statement. What are we missing? But then we're also going to continue on, how do we solve it? How do we make sure we get what we need to get? And this applies not just to laser scanning, but also UAV photogrammetry. I'm seeing a lot of departments that are using UAVs to map their scenes. You may be surprised at what you're missing. So today's webinar is not just to show you what you might be missing, but then also to go back and figure out how do we not miss things? How do we not miss the mark at our crash scenes? So that's the intro for today. So again, my name is Chris Lutz. I'm with Trimble Forensics as the training coordinator and also the marketing guy for Trimble Forensics. So unfortunately, you're going to be seeing a lot of my face. So let's do a brief rundown of what we have here. You may notice I have my TDC 600 here. That's acting as my remote control for my stream so that I can switch cameras and switch audio and all of that good stuff. So behind me we have our Trimble X7 that's currently working. I'm doing just a real quick 2-minute scan. I've done 2 7-minute very high density scans with HDR, so giving you the best possible laser scan of this scene that I possibly can in a reasonable amount of time. I've done 2 7-minute scans with HDR imaging. Again, our scanner does do HDR imaging. So I've done 2 of those to document this scene. Okay, so out behind us, I'm going to switch over to camera, I believe it's camera 3 here. Yeah, let's just switch over to camera 3. Okay, so right now you're looking at camera 3, which is our scene overview. Now, what we have here is a pair of, well, it's actually 4 skid marks here. And what I've done is, this was the final resting place, or the final rest for the vehicle at the end of the skids, and I've marked it out in chalk, so we know I was able to move it, so we're not cluttering up our scene. Well, we've got a set of really. So what I did here is got up to a certain speed, put it in neutral, turned the key off, and then dynamited the brakes. So these aren't ABS skids, as the trained eye can see. These aren't ABS. These are just lock-up wheel skids to final rest. And end of the broadcast today, there is going to be a little bit of a contest to determine how fast I was going. So you're going to have to be within 3 miles an hour of my speed here. So with that, the friction that we're going to use for this roadway is a 0.80 for these skids on the roadway. Okay, so we have 4-wheel lock skid marks coming out here, and they come to our scanner. So I'm going to walk back here. Change over to camera 2. All right, and as I'm walking towards you here, you can see the skid marks laid out behind me. Now the question is, where do these skids begin? As we're looking down this line here, where do they begin? And the really important question is, where do we think it begins with the laser scan? Okay, pure laser scanner. Now it doesn't matter whether it's a Trimble scanner or one from another manufacturer. All laser scanners operate the same in that they are sending out pulses of light, and they're taking what they get back and they're recording it. Now it may get what you want, it may not, but that's the nature of laser scans. They're their own light source, and they're recording what the beam bounces off of and comes back. So with that, let me kick back over to camera 1 here. So with that, the question is, how dark does a tire mark need to be before the laser scanner can recognize it, before our eyes can see it in the laser scan? How intense does that mark have to be? And question number 2 is, are we getting the entire tire mark? Are our instruments able to document it just laser scanned? Okay. Now, if you have a terrestrial laser scanner, we have the Trimble X7 out here today. But again, it doesn't matter what manufacturer it is. The question you should be asking if you are using a laser scanner for your crash scenes is, am I getting everything? Okay, that is the question. Again, don't care about manufacturer. There are a lot of other good laser scanners out there. However, the X7 has a very unique feature to laser scans, or to laser scanning, and especially crash scenes, and especially detecting minute objects such as the beginning or the shadowing of a tire mark. The X7 has a very special tool to document where those things are at. So that's what we're going to be doing, is we're going to be looking at our laser scans, seeing where do we lose the tire mark in the scans, and then question number 2 is where does it actually begin? Question number 3 is how do we document it? So let's get to it here. I have my T10 tablet here, and just bear with me just one moment. I've got a scan that I need to download. And you may notice that I've got an extra little black adapter here. And this is a second Wi-Fi adapter, and this allows me to screencast my screen to you guys. Now, this isn't a function of the instrument itself. The instrument itself is using the tablet, and the instrument, this black adapter here, is just for me to be able to live stream out to you. And just bear with me here. I am working on getting my scan synchronized, and of course, things don't always go according to plan, especially with Wi-Fi connectivity. All right, so while we're working on that, I want to talk to you about the comment section. Now, I'm not able to check it right now. Towards the end of the live stream, I'm going to check it and then answer any questions you guys may have. So if you have a question, post it in the comments section, and I'll go back towards the end of the stream here and take a read of them. Get our scans synchronized here. Okay, next thing I want to talk about is our contest. Now, I talked about figuring out the speed of the skid marks, and that's going to be the contest for today, is figuring out the speed of the scan, or speed of the tire marks when I laid them down. All right, last thing here is I'm going to details, and I'm going to process these images here and get them started. All right, again, sorry for the distraction. Okay, so we're going to talk about today's contest. So today's contest, or today's giveaway, is to figure out how fast I was going when I laid down these skids. And again, it needs to be within 3 miles an hour. I have 2 Trimble Forensics patches here. I'll get right up close here so you guys can see them. So these are going to be a Trimble Forensics patch. They're Velcro on the back, and it does come with the round Velcro backing. And I have 2 of these for the people that can get me the correct answer at the end of the live stream. Again, within 2 miles an hour or I'm sorry, 3 miles an hour. I'll make it. We don't want to split hairs here. So within 3 miles an hour of what these skids were actually laid down at. So at the end of the webinar, I'm going to give you the last of the information you need to make that determination. And the first 2 people that give us the correct answer within 2, we're going to mail you out one of our 2 Trimble Forensics patches. Okay, so let's get to it here. What I have, I'll plug in my adapter here again, so you guys can see my screencast. I think I need another set of hands, really. All right, we should be in good shape here. Let me kick over to my full screen. Make sure that everybody can see it here. And of course, the things are not playing too well with me today. I'm going to blame it on the thunderstorm last night. So we had some storms that moved through last night and just broke all kinds of stuff. So yeah, you know what? That's what I'm going to blame it on. Yeah, I think I'll just blame it on the storms. Okay, so let's transition over here and show you my capture screen. All right, so right now you're looking at my tablet screen. I'm just going to make sure that that's working like it should here, and it sure is. Okay, you're looking at my tablet screen, and this is the laser scan that was done. This was just a real quick 2-minute scan. The question is, where do these tire marks end? And it's looking like to me that they get lost somewhere right around in here. So just adjacent to this this tar mark here, I start to lose them in the photographs. If we jump over here, if we turn the photos off and we look at this in color-coded intensity, again, this is the infrared intensity. I pick it up just a little bit further back. So if we measure out the distance here, from this point to, I begin to lose it right about here. You know, that's another meter, so that's another 3 feet that we get out of that mark, but I start to lose it right around in here. And I just can't see it any closer or any further back than that. So let's take a look at where does this mark actually end? What are our longest tire marks? So let's jump over here to seam 2. There we go. So we'll jump over to 2. I'm going to come walking back here, and as you know, in crash reconstruction here, this is the way that you locate tire marks, is you get a long way back, and you get down on the pavement here. Oh, let me get... There we go. So we get down here, and we start looking. Where do we start to see them? And where I start to see these, there's a little bit of a rock out here. Let me just walk down here. Find this mark. Now there is where I start to see this mark is right about here. Is where I start to see this, and I've got some rocks that are knocked out here. So this is the start of my skid mark. Is right here. Now this is the interesting part, is that how do I document where that is? Well, when we were talking about our X7 having a unique feature, the X7 has the laser pointer, or the precision point feature. And this is something that no other laser scanner on the market is going to give you, is the ability to have it work like a total station. Now, one of the ways that we would mark this is we could put down some chalk. We could always put down some chalk. But another option available to us here is to turn on the laser pointer. And that's what I'm going to do, is I'm going to turn on the laser pointer and have it point at my toe, and we're going to document where this thing is. I'm going to turn on my, my full screen here of capture. So you can now see my screencast. What I'm going to do is I'm going to turn on my laser pointer. And what I'm going to do is I'm going to create an annotation, create new. I'll call this the left skid start. And what I'm going to do is I'm going to move my laser pointer over to where my foot is. And of course, you can't see it on my screen. And of course, my wind has now made my scanner move just a touch. Just enough so that the back over here. My scanner has moved just enough, being up high, and in case you can't hear it, this microphone does pretty well at filtering out wind noise, but it is awfully windy out here, and the instrument being up that high caused it to throw an error on me that it had moved, and the slightest bit of movement will cause that error. And you may be saying, well, that's dumb. You know, why would they make an instrument that is that vulnerable to wind? Well, it isn't that the instrument is vulnerable to the wind. It's that our instruments are so sensitive that they are able to detect the slightest bit of movement to guarantee you that your scans are correct, that we aren't just giving you junk data, that the instrument isn't moving around and the instrument can't sense it. It senses that it can, or that it did move, and well, it tells us that it moved. So what I'm going to do here is just do a real quick 2-minute scan in order for the instrument to orient itself. All right, while we're waiting for that scan to take place, now this is going to be a 1 minute and 35 second scan, again, just to orient itself. Right now I've got some poles out here, I've got some solid planes back behind, so it'll go pretty quick to orient itself. And you notice that I dropped it down, and if you are getting a lot of wind like we have out here today, we've got quite a bit of wind. Okay, while we're here, right before that scan takes place, what I'm going to do is I'm going to mark where we lost that scan in the infrared, which was right here. We've got this, we've got a tire mark that comes out here. I'm sorry, a tar mark that comes out and stops right here. And that is where I lose it. However, the mark actually stops back there. Let's come back here and find our tire mark again. Just gonna set this tablet down. So again, I can get down on my hands and knees and go look at where did that mark stop. All right, so I have got it right here. All right, so I have got the tire mark stopping or beginning right back in here. Now, you may be able to tell from camera 2, I'm going to kick over to camera 3 here right quick, and maybe this will give you a good idea, or a good idea of scale. So from camera 3, which is down by where my vehicle stopped, you may be able to see this green line on the pavement, maybe not. Okay, so my scan number 5 is registered to 4. Transfer over here so you guys can see my screen. Okay, this is scan number 5. We can see here, this is where we believed the mark ended, but in actuality, it's back in here somewhere. So what I'm going to do is turn my laser pointer on, and I can now see my laser pointer on the pavement. Bring it back up here. Yeah, let's see if I can find it again. You know, what I'm going to do is take a piece of chalk here and mark that. So I'm just beyond that black dot. There we are. All right, give myself a little bit of shade here. figure out where my dot is, or where my laser pointer's at. All right, so what I'm going to do here is I'm going to take it and I'm going to walk it. On these bright sunshiny days, it can be a little bit of a bugger. Like, okay, so it is clear back here. I was being a little optimistic on where I was able to find those marks before. There it is. All right, so what I was able to do is I was able to find this black mark that's down in here. I found this little landmark. And what I'm going to do is I'm going to move the laser pointer over. You know what, let me grab a camera here so I can show you guys. Position over and see if I can get that down low enough. Not sure if I can or not, but you know what, this one might be a good one to just grab the camera off the tripod here and go free cam with it. All right, so question for you all as well is, would it be helpful for me to have a hat or something like that I would be able to put these cameras on, and as I walk around, you'd basically have a first-person view to it? I don't know, but you know, I'm gonna throw it out there. Okay, so I've got camera 1 here. Got it down. Let's see if I can get it down here. There we go. Got too many things in my hand. But I've got my laser pointer there, and when I switch back over, capture full screen, what I'll do is I'll move that laser pointer to the point where I see that tire mark. So, all right, bear with me here. I have got to set some things down. I got way too many things in my hands. Okay, so I've got you may be able to see it. I've got my laser pointer right here. And then I'm gonna go back to my capture full screen. I'm gonna move this dot right where I see that mark going away. You can see there I've got my pointer where it needs to be. All right, from here what I'm gonna do is I'm gonna create a new point. This is gonna be a precision point. Make sure you guys can see me here. Capture full screen, there we go. All right. I'm going to call this one the end of the tire mark and true. I'm going to scan the point. While I'm at it, I'm going to take a photograph. All right, I'm going to create that point. And now there is our true tire mark where it ends. And as you can see, you can't see it on the LiDAR data. We have got a lot of tire mark here that is missing from the LiDAR scans. And so you have a couple options here. One is that you can go out and you can mark these scenes up with paint and carry around the paint in your trunk, which paint's always good to have. I mean, don't get me wrong, paint is a very good thing. I've gone through cases of it. But I think for about as many cases as I actually used on the pavement, I probably had just as many explode in my trunk as I did actually use on the roadway. So it's something interesting to consider in that maybe you don't have to carry around a whole bunch of paint. Maybe, let me get back over here, maybe you don't have to carry around a bunch of paint. Maybe you could use the X7 and the laser pointer feature to make sure that you aren't missing the mark. Now, here's what we have missing in that tire mark. And we can't see it with our eyes from this distance or from this vantage point. We definitely can't see it in the LiDAR scans. But what we can do is get down on our hands and knees and find out where, or figure out where that mark begins truly. Let me adjust this one more time here. We could see where that mark truly begins, okay? And again, it's something that if you're out laser scanning your crash scenes and scanning and scanning and scanning, and it's something that's kind of been told is that you just set a scanner up, you push a button, and you get a perfectly accurate mapping of your scene. While we do have the dimensional accuracy of the things around us, you may be missing the mark. You may be missing a lot of your tire mark that isn't showing up in your LiDAR data. So using the X7's laser pointer or precision point feature is one way to go about it. The other way to go about it is to use the Trimble GNSS. Kick over here to number 3. I'm gonna go and get my my R4. Now my R4 SLE is a survey grade GNSS receiver, but it's built for us cops. Okay, it is purpose built for law enforcement. So one of the ways that we can also document our scene, especially these very faint tire marks, is with our R4. And again, with the capture software, I did a webinar here, about a month or so ago, where I used the R4 and X7 on the same scene to go out and document a parking lot and do what's called georeferencing, or the alignment of GNSS data with my laser scan data. And again, these two tools work very well together. They're built to work well together. And GNSS is another way. You can come out and you can place a definitive point on a spot and say, this is where that tire mark began. So what's interesting here is we need to take a measurement. Let me get this bumped down just a little bit. Okay, so what I'm gonna do here is I'm gonna take a measurement and show you guys how much tire mark we're actually missing. So I'm gonna add in another dimension here. And I'm gonna go from our tire mark, from the true end of our tire mark, over to here, where we lose it in the previous laser scan. See there, we begin losing it right there. And that's a total of 3 meters, okay? 3.348 meters. Almost 10 feet of skid mark that are missing from our scan data. And again, this is not unique to Trimble. This is every manufacturer scanning crash scenes has this effect, that very minute evidence that our trained eyes are trained to see may not be picked up in your LiDAR scan data. It might, or it might not. Now the one thing, or the one advantage you have here with this system is that you can actually see that, hey, I can't see the end of my tire marks in my data. The other option is you can scan your scenes and go back to the office and figure out your missing data. It's up to you whether you want to do it and whether you want to figure out that, hey, I can't see something in the field, or you go back to the office and you can't see something. I think I know which one I would pick. Okay, so we have our tire marks here, and yeah, we've got them documented. This is the area where all 4 of the tire marks begin, so we're just going to use this measurement here. Now, again, this is going to be for 2 of our Trimble Forensics patches. 1 apiece. You don't, unlike most things, you don't have to be present to win these. So here we go. I have 2 Trimble Forensics patches, and these are going to go to the first 2 people that can send us a message with the correct speed at which I locked up the brakes and slid to a stop. Now you have to be accurate to within 2 miles an hour on this. 2 miles an hour. Okay, also in that message that you send us, please send us the address you would like your patch shipped to. Yeah, it's a little hard for us to send you something if we don't know the address to send it to. So Send at the end, or as soon as we wrap this up, send us a message with the correct answer, along with your address, and we will ship you out one of our patches. Okay, let's get our final measurement here. So I'm going to jump back over to capture, and we need to take a measurement, and we need to measure from the beginning of our marks to the end of our marks. So I'm going to take a measurement here. Take a measurement here. Yep. All right, so I'm going to turn that one off. We're going to go from here all the way back. This point right back here. And the total length of our skids is 21.509 meters. So we'll just truncate it to 21.5 meters. That's the length of our skids. Again, we're using a drag factor of 0.82. So 21.5 meters of skids, a drag factor of 0.82. Wonder what that is. All right, so let's go back to our camera here. And what I'm going to do is I'm going to check my messages here and see if if anybody's left me any comments. We got an I love Trimble. Well, thank you, sir. We certainly try our best. All right, I'm not seeing any comments, or at least back here. Okay, not seeing any questions. All right, last call for questions. Again, last call for questions. Going once, going twice, gone. Okay, so that concludes this week's Wednesday workshop on missing the mark. What are you missing? Now, we're also going to give some bonus points here. What did we have? 3.3 meters of missing tire mark. So bonus points. I'm going to give bonus. You know what? We're going to double down on this. There's going to be some bonus points. So what do we have? 3.1 or 3.3 meters? Let's go back and look. Okay. All right, bear with me here. And of course, when I transition away, now it pops up. Okay, so I'm going to go back to station 5 here. We're going to measure out. And of course, wouldn't you know it, I deleted that measurement. Yeah, so it was 3.3 meters. So with 3.3 meters at a 0.82, what's the speed difference that we have here? So the first part of the contest, you're going to get a patch. Again, the first 2 people that can send me the correct answer within 2 miles an hour on this, or on these skids, so we have 4 skids at 21.5 meters, okay? We're also missing 3.3 meters from the original. So work it out for extra credit. We're going to throw in 2 challenge coins. So for extra credit, if you want a challenge coin along with your patch, for extra credit, factor it up so that we have 21.5. Yeah, so we have 21.5 is the true length, and take 3.3 off of that. So if we had just relied on LiDAR data, if we hadn't used a precision point, if we hadn't used GNSS, if we hadn't done something else to get that additional length, take 3.3. What would be the speed that we would have calculated off of just the LiDAR data? And again, if you were using a laser scanner from another manufacturer, be asking yourself, what are you missing? How much speed would you be missing off of this equation? Okay? And this is just one example. If these were ABS marks, again, we know that ABS marks are even fainter yet. Some of those ABS marks are really hard to see where they begin. How much could you be missing? Are you missing the mark? Again, that's a question to ask yourself if you don't have a scanner with the ability to take a precision point. If you don't have another means, such as using GNSS, to document where those marks actually start, what are you missing? It's a good question to ask yourself. Okay, I'm going to do one final check here of my comments. Again, if you have any questions here, now would be a really good time to put those in the comment section so that I can get them answered. And I got a question from Caesar, closing already. Yeah, I mean, we're not ready to close up shop just yet. If somebody's got a question yet, I'll hang on for just a couple more minutes here. But yeah, so that's everything I have for today's broadcast, is just showing you guys how much you could actually miss if you're not using a laser scanner with a precision point feature, or you're just using a laser scanner and you don't have GNSS or an optical total station or something else to supplement your toolkit. If you're just going out with a laser scanner, what are you missing? Very good question. So that was this week's webinar. So I'd like to do another one next week, but I haven't quite settled on a topic yet. So if there's a question that you have, whether it's going outside and doing field work, if you want to go out and we can take the X7 out and go do something. If you want to scan a crime scene, if you want to go out and do field work, again with GNSS, I've got an SX12. So if you'd like to see something around the SX12 scanning total station, we can come out and do that as well. If you have a question on the software, whether it's Trimble RealWorks Forensic, whether it's Trimble Forensics Reveals or diagramming and analysis software, we can do something there. Or something else we can do is working with Showcase. Last week's webinar, or workshop Wednesday, or Wednesday workshop, I guess. Our workshop or Wednesday workshop was on quick turn deliverables using Trimble Forensics Showcase. Would you like to see something in Showcase? Would you like to, is there a question that you have? Is there something that has been bugging you, or something that you just can't figure out? Shoot it to us in a comment or a message, and we'd love to hear it, and would love to do a live stream workshop that really is tailored to you. So that's everything that we have. Thank you very much for tuning in. Hopefully this was worthwhile for you guys, and I plan on coming back again next week with another live stream, hopefully with something that's beneficial or something that is suggested from you guys. So stay safe, and I'll see you guys again next week.